how do we actually use this formula? Well, to be honest with you, you can use it in its raw form. So let's say, for example, I give you a curve like y equals f of x, and let's suppose my function is x squared. Okay, let's suppose my function is x squared. And let's suppose, this is my money, let's suppose this is time, and this is the amount of money I have in my bank account. Let's suppose that I want to find how quickly my money is changing at 3 years. Okay, so at x equals 3. I want to find how quickly is my money changing after 3 years. So how would I do that? Well, I would literally use this idea here. This idea, dy by dx, literally tells me how quickly is my money changing. How quickly is my money changing? So I know that dy by dx is equal to, well, I need to take the limit as h approaches 0, so I need to make h as small as possible, of f of x plus h minus f of x all divided by h. Okay, this will tell me how quickly my money is changing, right? This is just generally a function. Okay, so let's think about this. What would f of x plus h be? So f of x, remember, is just x squared. So what would f of x plus h be?
X squared plus h.
Not x squared plus h.
X squared plus f of h.
X plus h squared.
X plus h squared, you happy? Because x is the thing that I put into my function. Like, think about this, f of some input. So if my input is x plus h, then this x has to be changed to x plus h, yeah? So I'd have x plus h all squared minus f of x. What's f of x? Just x squared. F of x equals x squared divided by h. Okay, let's think about this. What's x plus h all squared?
X squared plus 2hx plus h squared.
Good. Plus 2xh plus h squared. Minus x squared, all divided by h. Oh, look, I can do a bit of cancellation going on here. X squared, negative x squared. Gone, right? So now it's just a case of doing a little bit of tidying up. So you notice I'm not thinking about this limit yet. I think about the limit last. So what's 2xh divided by h?
We can take the h as a common factor, like h times 2x plus h.
Well, are you happy that because I'm dividing this by h, it can cancel with that and that h up there? So in other words, what I'm going to be left with is 2x, because one of the h's is gone, plus h. Now think about it. What does this mean? What does this thing mean? Limit as h approaches 0. What does it actually mean?
H is equal to 0.
Not equal to 0, but it approaches 0, so it gets pretty close that it basically behaves like 0. So in other words, it's so small, it doesn't matter. So therefore, anything with a h in just becomes really, really small. Happy with that? Good morning. Yeah? So in other words, what I'm left with is 2x. I'm left with 2x. Okay. I'm left with 2x. Now, what does this 2x correspond to?
So that's the derivative scheme today.
So this here is my derivative. But this is weird, because when we were dealing with gradients before, when we were dealing with gradients of straight lines, we just expected a single number. In fact, I just want a single number here, because I can understand that. Like if it's a big number, it means it's changing quite quickly. If it's negative, it means it's decreasing. It means it's getting smaller. But what does this mean? This is supposedly my gradient, but it's still got x's in. What does it mean? It is still to do with gradient, but it's not the value of my gradient at x equals 3. It's my gradient function. It's my gradient